Some of the word problems that you're going to solve will come with the equation, and all you need to do is just plug in the number. Sometimes they don't. If they don't come with equation already, then we have to know how to write them ourselves. Okay, so exponential growth or decay, they both look very similar. The growth function goes like that. The ending amount, let's say a of t, is initial amount times 1 plus the rate, getting raised to the tth power. This is the growth function. So you read the scenario, you read the word problem, it may be like population is growing or money is growing because of investment. Then you're gonna use this growth function, okay? But it may be decaying. Maybe we're talking about maybe like half-life, or something is, I don't know what else, like a car value. Let's say like a used car value is going down. In that case, then you want to use the decay function, which looks exactly the same, except instead of 1 plus r, you're going to have 1 minus r to the tth power. And if you have that, that is a decay function. Okay, so right here, I was just giving you both of them at the same time, where A stands for the final amount. Okay, A stands for, the little a stands for the initial amount. How much is your Honda Civic right now? Or how much is this, how much do I have in my savings account right now? You know, what do we have right now? Or initial amount. R is the rate of increase or decrease. I think today, in these examples that we're going over today, they will be given to us. Later on in the section, in the chapter, we're going to learn how to solve for these rate. So you may be thinking about questions like, if I want to have $5,000 and I have $3,000 today, what kind of interest Wells Fargo or BB&T must offer me so that I can have this investment goal? You know what I mean? Something like that. Anyways, and for T is the number of time period. Oftentimes years is going to be a common one. But let's take a look at a couple examples together in this video, okay? In the formula, the base of the exponential function, 1 plus r, if you're adding, this is the growth, right? So if you have 1 plus r, this is called the growth factor. Okay, 1 plus r is the growth factor. Well, if you have 1 minus r, the base, this is going to be the decay factor. Just, you know, some terms that I may be using today. So I want to give it to you. Alrighty, let's look at example 1 together, which comes with equation already, so that's good. This is going to be the easier one, okay? We don't have to write our equation. It says, if the rate of inflation is 2.5% per year, that means it's getting more expensive, right? It's going up, it's increasing. The future price, what are they talking about? Not a specific item, but like, for example, the price of a car in 1980 is probably much cheap. Oh, well, probably car is not a good. How about a house here? Price of a house in Woodbridge is probably much cheaper back in 1980 compared to right now, don't you think? So the future price P of t of a certain item can be modeled by the following exponential function. Okay, so they gave us a function where t is the number of years from today. What do they want? Guys, I think I have a typo here because I was typing up this note and I was supposed to ask you a question. But you see, I didn't even ask you a question, right? So how about this? I'm about to ask you, I will create the problem here, okay? Part A. What is the initial value of this item? What is the initial value of this item? If you take a look, the initial value or the initial amount is the coefficient that's getting multiplied by the by this exponential term, right? So if you look carefully on this equation, can you see that the initial value is 1500? So initial value of this item is 1,500. Let me ask you a couple more questions then, okay? How about this? B. What is the growth or decay factor? I'm trying to be creative here. First of all, is this the growth or decay? Well, I know if this is growth, if the factor is bigger than 1. If it's smaller than 1, then this is a decay. Take a look at the factor right here. You see, the number is 1.025. They got this by doing 1 plus 0.025, right? Because the percent was 2.5%. So the growth factor is 1.025, and this is a growth factor because this is greater than 1. If the number is smaller than 1, for example, let me make something up for you. If you have an equation that says 1,500 times 0.95 to the teeth power, that will be a decay function with a decay factor of 0.95 because the base of this exponential function is smaller than the 1. Okay, so we know this is a growth function with a great growth factor of 1.025. Can I ask you another question? Let me try to come up with another one. Okay, how about this? What is the price of this item in, hold on, let me move this up, in 10 years? In order to answer this question, we're going to have to plug in 10 into this equation, right? So let's try that, and that should be enough for this example. I forgot to type up the example. Can you see? All right, P of T equals 1,500. It used to be 1,500 in year 0, but if you wait 10 years, I bet it's going to be more expensive. So let's plug in 10. And I'm going to get an approximate answer, and I'll just round to the nearest cent, okay? So I'm going to go to my scientific calculator. Okay, I'm on the scientific calculator, and I'll go ahead and type in, hold on, let me show you what I'm typing in, okay? 1,500 times 1.025 raised to the 10th power. Oh, in 10 years, this certain item will be $1,920.13. Yep, that's how you can just use the equation given to tell some important parts. I think that was good. I forgot to type the problem, so I just created them, created part A, B, and C, but I think that's going to be similar to what you will see on your Alex homework. All right, let's do example 2 too. Let's see, how long have I been going so far? About 8 minutes. Let me do example 2, and then I will stop this video and come back on another one because I don't want to make it too long. How about this? A car is purchased for $1,800. A small, like Corolla maybe. After each year, the resale value decreased by 20%. Isn't that so true? You buy a car, and in 5 years, it's like worth less than what you still owe. So it's an exponential decay function. It's going down by 20%. So what I will do is I will subtract 20%. That makes sense, right? So the function is, I'm going to copy down the formula. A of t equals little a times 1 minus rate raised to the tth power. Okay, I know what little a is. Little a is how much is this car today, which is $1,800, right? And in the parentheses, I will do 1 minus the rate. And do you know why this is minus, right? because this is they said it's decreasing. So this must be exponential decay function. And 20% in decimal is 0.2, 0.20. So I'll subtract 0.20 from it, and then I'll raise that to the teeth power. Did they give us what t is? Looks like it. They asked specifically for t equals 3 after 3 years. So that's why I'm going to plug in 3 as its exponent. And what I'm going to do is I'm going to evaluate this, okay? I'll go to my scientific calculator to do this, okay? I'll go down here and I'll type in 18,000 times 1 minus 0.20. What they are saying is every year, the car is going to worth 80% of what it used to be in the previous year. That sucks. All right, raised to the third power. So if you have a nice little Corolla today, in 3 years, it's gonna worth $9,216. Alrighty. Alright, so that is the answer. $, $9,216 even. Okay, so we saw 2 examples of exponential. One was growth, and the bottom one was decay. I will come back and show you the other 3 examples in page number 6 very soon, okay?